It just edits it out. Together, we talked about this notion that drawing a sample and trying to predict for the entire population may very well be a very accurate way of predicting for the whole population. Trying to figure out who's going to win the next election. Okay. Drawing a sample and predicting the election just based on that sample might be very accurate. Now, a couple key things we want here. We want that sample to look as much like the population as possible. We're going to talk today about how we can achieve that. And for sure, we don't want that sample to include any biases. Now, on your homework last night, we're going to talk about some more biases. Number 8, the words voluntary response bias should be somewhere in that answer. You not only have to identify what type of bias it is, but then talk about it and say what it means. So get used to the vocabulary as well. But we don't want to draw a sample that is systematically favoring one outcome over another. I don't want to be standing outside the Republican convention asking people as they walk out, hey, who you vote for? And then make that my sample for predicting for the entire population. Remember, that was called convenience bias. And obviously in that situation, we're going to be systematically favoring the Republicans in that particular sample. So we want our sample to look as much like the population as we can without any biases, okay, so that when we look at our sample, we can predict what the population looks like. All right, the best way to attack biases and to get rid of them is to make sure you randomly select your sample from the population of interest. Just by randomly picking them, rather than standing outside a Republican headquarters and having people come to me and tell me who they're voting for, I need to somehow randomly get a sample of people from the entire population. And that way nobody can say, hey, oh, you're just favoring the Republicans, you're standing outside their office. Or better yet, remember, let's say we got this new pill that's going to cure the common cold. So I'm going to create two groups, right? I'm going to create one group that actually gets the pill and one group that's not going to get the pill. We don't want somebody else saying later, oh, you just put the healthier people in that group that was getting the pill. That's why they got better. No, no, no. I am going to randomly put the people into these groups. That eliminates all your lurking variables that you're going to give me about problems with the two different groups. Okay, so randomness is the key. In fact, this is like my least favorite day of the year. 3 of you are going to get half the homework tonight. You're going to have half the problems to do. 3 of you. So I'm going to choose 3 of you, and you only have to do half the assignment. Now, would it be right if I don't like you. Yeah, I like you. I'll give you half. I don't like you. I like you. I don't like you. I like you. Is that fair? You guys happy with that? No, there's definitely a selection bias there. I'm picking people I like. You wouldn't be happy about that. So what's the only way to get around that? I need to randomly select from you. Think about it when we do the homework assignments on the board. Isn't that randomly done? Okay? Everyone's got a chance to be in that sample. So that's what we're going to do in a minute here. I'm going to choose 3 of you randomly, and you're going to have half the homework on tonight's assignment. In fact, what I'm going to do is something called a simple random sample. Okay? And it's the best. If you can achieve this, it's the absolutely best sampling technique that you can have. Now, there are 2 criteria for a sample to be what's called a simple random sample, and it's going to confuse you. The first thing, in order for the sample that I choose to be a simple random sample, is that every group has got to have the same chance of being selected. And the problem we're going to do here in a minute, I'm going to choose 3 of you. What this says is that group of 3 that I select had to have the same chance of being selected as any other group of 3. give you an example. Maybe this will help you clear it up. Let's say it's two different ones. Let's say I have 40 students in class. I've got 20 girls, and I got 20 boys. And I'm going to choose 4 people out of the class that only have half the assignment tonight. I'm going to choose 2 girls, and I'm going to choose 2 boys. All right, first question I have for you. Do you think that anyone in this class would be getting ripped off if I did this? In other words, do you have a better chance of getting in than you do, or do you have a better chance than someone else? Seeing a lot of shaking heads, no. Yeah, I agree. Every person has an equal chance to get in. Okay? And that is one of the criteria for a simple random sample. Each individual's got to have the same chance of getting in. But the bigger one is that every group of 4, remember I'm picking 4 total people in this situation that are going to have half the assignment? Every group of 4 people have the same exact chance of being selected. Is that the case in this little example I came up with? Does every group of 4 of you have the same chance of being selected? Shake your head, no. Why not?
Well, because you have to have 2 girls and 2 boys.
Right, so what's one group of 4 that doesn't have a chance of getting selected?
All girls.
Yeah, if I put all the names in a hat, and by the way, that's one of our favorite ways of drawing a simple random sample. If I put all the names in a hat and I picked 4 people out, could I possibly get 4 girls and no boys? Does that sample even have a chance of ever being selected? No. Okay? So this is called stratified sampling. We're going to get to this in a second. But this isn't a simple random sample. Even though everyone's got the same chance, on an individual level, no one's got a better chance than someone else. Now, if I'd have had, 30 girls, would then have everyone had the same chance of getting in? No, I kind of ripped off girls in that situation. But in this situation, every single person's got the same chance as everyone else of getting half the homework, but not every group of 4 students has the same chance of being selected. There might be 4 girls selected, and you got no chance to even be a part of the sample. So a good simple random sample will meet both of these criteria. So just be real careful about it. The first one's the tricky one. All right, so what are some ways you can draw a good simple random sample? Well, the first one is draw names out of a hat. That's the simplest way. On May 10th, if they give you the option to draw a simple random sample, draw names out of a hat. It's the easiest one. You're done. Move on. If you've got to choose 30 fish out of a bowl, give every fish a name and draw the names out of a hat. It doesn't even have to make sense. Okay? Draw them out of the hat. That's the easiest way. However, they're not going to make it easy on you probably on May 10th, and you've got to come up with some other method to make sure you draw a simple random sample. How I choose you guys to go on the walls on test days. Isn't that a simple random sample? Think about it, right? Everyone gets a number, and then I let the calculator randomly choose 3 of those numbers. Yeah, that's a simple random sample. If I have 3 problems on the board, doesn't each group of 3 of you have the same chance of being up there? You bet. Okay. Now, unfortunately, on your test, they're not going to let you use that little calculator technique. What they're probably going to do is make you use a set of random digits. Go to your book, to the very back of your book, it's Table B. Actually, I learned last period that some people don't have a Table B. Most all of you should. I'm going to make some copies of Table B, so if you don't have one, just borrow with someone today when you're doing your work, and I'll have some copies tomorrow. You should have, it's on the very back, very back, very back! Find it. If you don't have one, I'll get some copies tomorrow. It should be all grimy. Your founding fathers have been working on Table B out of these books for a long time. There'll be pencil marks in there. Go ahead and erase them if you want. It's okay if it's there. Just gives you an idea of how much you're going to be using Table B. Now, what Table B is just a collection of random digits. Do you notice how they're in groups of 5? Forget about that. They just did that for you so you can kind of organize the numbers. Each digit in there was randomly selected. There are people with PhDs, maybe they won Nobel Peace Prizes just to be able to come up with algorithms, programs that come up with random digits. Our calculator does it. I have no idea how it does it. Somehow they just put these digits in there randomly. Now don't worry about the 101, 102. That's just saying what row you're on. But those digits, 1, 9, 2, each one is an individual digit, and each one is placed there randomly. There's no pattern at all. believe me? All right, so how can we use these random digits to come up with my sample? Well, it's much like we do with the calculator. The first thing that you're going to do is you're going to assign a digit to everyone. Okay, we're going to do that right now. We're going to assign a digit to everyone, and 3 of you, somehow, some way, are not going to have to worry about half of the homework tonight. So let's go ahead and go. Go.
4, 5, 6, 12, 13,
14.
15, 16, 17, 18, 19, 20,
22.
24,
25.
26, 27,
37. 33.
Now, it's nice in my calculator, right? Don't I just say 1 to 33 and I always get digits from 1 to 33? Well, this random digits, we don't have that option. Okay? So right now, you're going to need to, and on your homework tonight, explain to me fully how in the world you're going to use those random digits to come up with 3 names that only have half the homework tonight. Okay, well, the first thing you do is you assign everyone a digit. So you write all the names down and they have a number associated with them. We're roughly in alphabetical order here. It doesn't matter how you give them their number originally because we're going to randomly pick those numbers later. Okay, now this is the part that really confuses a lot of people. So I'm looking at this. The first digit I see is a 1. Does that mean you win? No. Here's my question to you. How many digits at a time do we need to look at? In groups of how many? How many digits at a time do we need to look at for this situation in order to choose 3 people? 3 digits at a time? Okay, so I need to, what I'm saying here, so I need to look at 192. I need to look at 3 digits at a time in order to choose 3 people from U31. How many digits at a time do I need to look at? 10 digits at a time. So I need to look at 19223, 95034. I need to look at all those in order to choose somebody. 6 digits at a time. You guys are killing me. How many digits at a time do I need to look at? 2. I need to look at 2. Now, don't get excited, 19. We're not starting with you. But if I look at 19, doesn't that represent somebody in here? And I only need to look at those 2, right? So what is your winning digit in here? What number, looking at 2 digits at a time, would you be? What's your number? 1. So who's going to be you? 1? Is 1? I find a 1 and she gets no homework? 0, 1. Right? If I'm looking at 2 digits at a time, 0, 1 is going to be Bree. 0, 2, and so on. You get the idea? Okay. Let's say this class had 12,347 people in it. And I'm going to pick 3 of them to be my sample. How many digits at a time am I going to have to look at now so that every time I look at them, I'm going to find a digit?
5.
Yeah, I'm going to have to look at 5 digits at a time. That's what I need you to explain to me on your homework tonight. So in this particular problem, you would say, I'm going to look at 2 digits at a time. All right, now we have another situation, and you have to fully explain this to me tonight. What are we going to do if we get, let's go down a little bit, 95. Let's say those are the 2 digits I'm looking at, the number 95. What are you going to do with the number 95? Skip it. Ignore it. You need to explain that to me. So you would say that numbers outside of the range will be ignored. That won't always be the case, but in this case it would be. What if I get the same number twice? What if I get 0, 1 and I get 0, 1 again? What do you guys want to do with that? Should I just make her not have any homework? Yeah. Really? What do you think we're going to do? What do we do in class when the same number comes up and I have somebody doing problems on the board? You ignore it. All right, so here's the sentence that I have to have before you do any work. I'm going to look at 2 digits at a time, ignoring repeats and ignoring numbers outside the range. Sometimes you won't have any numbers outside the range. You don't have to worry about it. I got a trick question for you. Let's say my population, let's say this class only had 10 students, and I was going to pick 2 to be my sample. How many digits at a time would you need to look at if you had 10 students? This is the real tricky one. 2 digits at a time? Now when I look at 2 digits at a time, I'm going to have a lot of outside the range, right? So you could do it that way. 1 digit at a time. Aren't there 10 digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in that situation, you would have nothing outside of the range, so you don't have to worry about it. Okay? But you need to fully explain how you did your randomness. You don't want someone coming up to you later, oh yeah, you just put the healthy people in there. No, I randomly chose, and here's how I did it. Okay? So I need that on each one of the problems that you're doing tonight using the random digits to do that. Okay? Alright, here we go. We're going to do it now. Now, we're not starting at 101. Now, you're not going to have to do this. They're going to tell you where to start, so you're not going to have to do this. But in fairness, I'm just going to put my finger down, and wherever that thing lands, that's where we're going to start looking at 2 digits at a time. Alright, here's where I'm at. I'm on row 124, and I am on the 25th digit. That's why they group them in 5, so you can go find that pretty easy. Go find the number. That's the 25th digit on 124. What number are we at? 124. 10, 25, 26. I'm on a 9. I see a 9. Does everybody see the 9? It's actually 96 if we're looking at 2 digits. Alright, so here we go. So tonight this is what you're going to do. You're going to write down the number 96. What are we going to do with it? Ignore. You should write ignore. Let's keep going. Everybody's looking for their number now. 75. What are we going to do? Ignore. 82. Remember, there's no space there. These are just random digits. 82. What are we doing? 76. 11. Am I doing it right? 82, 76, 11. Who's no? See, that's just proof right there. There's no way I would allow half credit, half homework for him. So this is unbiased. Let's keep going. 91? 91? 59. All right, now we're going to kind of do a little wraparound action here. 69. 67. 46. 12. Oh, man. 12. Then 14. Who's 14? Oh, man. I guarantee you I would not give him half homework tonight. Those are your winners. Are you guys happy about it? No. But was there any bias on my part? Did I systematically favor certain people in here? No. And that's the point of it. There was no bias in my selection, and we're hoping those 3 are a nice cross-section. Hey. We're hoping those 3 are a nice cross-section or a nice representation of our class. I don't know if we got one, but at least we had no bias when we were doing our selections. Okay, so you guys got the evens tonight. So you're only doing the evens on tonight's homework. Okay, on a couple of problems tonight, you're going to be using the random digits in the back of your book. Make sure you write me the sentence. Tell me how many digits at a time you're looking at. Okay, what you're going to do with repeats and numbers outside the range. Probably going to be ignoring them. Okay, then you're going to do the numbers, tell me what you do on each one of them, and draw your sample and tell me who your sample is. The first thing you're going to do is going to give each person a digit. Okay? Alright, like I say, this is the best. However, there are other type of sampling designs that do have randomness in it. Now, our result is not going to be a simple random sample here, but often you will want to use these types of designs for whatever reason. First one is called a stratified random sample. What if, I'm thinking that my pill is going to have a different reaction with men than it might have with women. So what I would do here is I would take the population and I would separate them into men and women. And then I would choose out of a hat to see who's getting the drug and who's not. Out of a hat to see who's getting the drug and who's getting not. That's called a stratified random sample. Still has randomness. Okay? But I've now first broken them into homogeneous groups. That means groups that are alike. You know, women are like women, men are like men. Yes?
So when they do study on like those, and maybe like, oh, people who have heart problems might not want to take
Often they'll stratify it. Often, sometimes they'll maybe say, okay, let's separate right off the bat. Let's put like healthy people here and non-healthy people here. And then let's do them in those two groups. Or maybe I won't even do it to this group. Okay? But often they'll stratify right off the bat. We're going to talk a lot more about this coming up. But just understand right now, if you break the population into groups right off the bat and then do your randomness, okay, it's called a stratified random sample, and it's not going to be a simple random sample, is it? Remember here, 2 boys and 2 girls? That's what I did here. I stratified into boys and girls. I got 2 of each, but it's not a simple random sample of 4 anymore. And the last one we're going to talk about right now is something called multi-stage random sampling. Hey, look, if I'm going to try to figure out, do a poll who's going to be the next president, so I got to take the whole population of the United States and I put each name in a hat. Then I go pick 1,000 of them, and then I got to go find all 1,000 of them. Okay, that's going to be rough, isn't it? A lot of travel, maybe, if I have to do, you know, some sort of experiment with them. Okay. Often, what they'll do to save cost is what's called multi-stage. So another way to do it is, okay, here's what I'll do. I'll put all 50 states in the union in a hat. Okay? Okay, I'll pick out 5. And then for each one of those states, I'll put all their counties in a hat. And I'll pick a bunch of counties randomly. And then I'll go to those various counties and I'll pick different neighborhoods out of a hat. Pick those neighbors. And then there I'll randomly pick 6 or 7 people. So then I just got to go to these different neighborhoods. I don't got to go to everywhere in the country. Again, not a simple random sample, but often that's the best you can do. Okay? But notice it does have randomness. Remember I said pick out of a hat at each one of the stages. Okay, so it's got randomness. It's not getting up a simple random sample, but it might just be what you have to do. Okay, I introduced 2 biases to you last time. I think voluntary response bias, which was number 8, was about, and then convenience bias. Now, a bias, remember, is you draw a sample. It's not going to look like the population. You're favoring one outcome over another. All right, let's talk about some other potential biases, things you have to be on the lookout for. Now, when you're doing your homework problems, identify the name of the bias as well as explaining why it is that type of bias. First one, undercoverage bias. 1936 presidential election. I think it was Gallup, too. It was a very famous polling organization. They got it dead wrong. They predicted that the Republican candidate was going to win the presidential election. Was going to beat FDR. We all know why. In fact, they thought it was going to be kind of a landslide. Here's how they did their polling. They got a telephone book. They picked names out of a hat. And they called those people and asked who they were voting for. Why did they get it so wrong? Why? And I want one of my 3 people that's got an easy night tonight to give me the answer to this. Why did they blow it? Why did they get a sample that wasn't like the population and they predicted the wrong candidate? All right, Elise, why?
Not everyone had phones.
1936 was like 6 phones in the whole world at that time. And who had the phones, do you think, in 1936? Rich people who are associated with Republicans. This is a great example of something called undercoverage bias. Look, when I draw my sample, I have to take my sample from the entire population of interest. If I was going to try to figure out, 3 people to have less homework tonight, if I just went over here, okay, you guys, we're going to put your names in a hat, I'm going to pick 3 of you. Would that have been fair? None of you have even had a chance to get in the sample. This is an example of undercoverage bias. All the people without phones had no chance to even be asked. And in their situation, they were more Democrats without phones, so they weren't even a part of the poll. So whenever you draw a sample, you've got to make sure that everyone in the population's got the same chance of getting selected. Okay? Or you might have some sort of an undercoverage bias. Number 2, non-response bias. That was me with that little old lady. Well, actually, when I first got the envelope and I didn't return it, that's non-response bias. And then the little old lady came to my door, asked me, shut it on her. And she came with the big guy, shut it on her again. That's an example of non-response bias. Now, why is there a bias there? Let's go back to that. Your college is sending me how much money you making thing. So let's say they send out 500 brochures, and they get 300 of them back. So I want 200 more in my study to try to figure out how much money people are making. Is it okay for me to go randomly select a new 500 people and then get their responses until I add up to 500 total? Is that okay? Jeff, say no. Why not?
Well, because you've got the non-response bias, which no one's going to say anything back, but then you've got the under-coverage bias.
Well, it's not under coverage here because I'm taking the sample from everybody. So assume I'm taking the sample from everybody. So let's think about this now. I send out 500, I get 300 back. Bill Gates is your clue here, right? So I get 300 back, but I still need 200 more to make my sample. Is it okay for me to send out a new 500 to everybody, not under coverage? I'm going to send it out to everybody, and then the next 200 that come in, they're the ones going to be in my study. Is that okay?
No, because the people are the people who send them back are taking the time to do it, so they're going to...
Well, it's not only taking the time. Remember on this example, who's going to send back saying how much money you made? It's the same type of people, right? The people with lots of money. So I've got 300 people with lots of money, and now I got a new 200 people with lots of money. Isn't my average going to be biased? So what I have to do is if I have 300 and I got 300 back and there's 200 still out there, I got to be that little old lady. I got to go find those 200 people. And I got to ask them how much money they're making. Then my average will be more representative of the population. Okay? So non-response bias. If you don't get a response, people won't give you the answer. They won't tell you. And that could definitely bias whatever you're looking at. Response bias. People may just lie. They might not tell you the truth. 1970s, there was a election, I believe, for governor of California. And it was a guy named Tom Bradley. And he was going up against some other candidate. Tom Bradley was the mayor of Los Angeles. Tom Bradley was black, and the other candidate was white. All the polls that came in said Tom Bradley was winning. It's going to be a landslide. Tom Bradley was going to win the gubernatorial race by a landslide. The votes came in, and he didn't win. A lot of people thought there might have been some response bias there. In other words, somebody comes up to me and asks me who I'm voting for. I don't want to act like I'm racist, so I'll give them an answer, but that really is not the truth. Okay, so it systematically favored Bradley, but that wasn't the right answer. Okay, some big flunky guy comes up to you and says, you know, got like a Romney sticker. Who you voting for? Romney. Go away from me. Okay? Response bias. Okay, so you might get answers for whatever reason that might not be truthful. That's going to bias your final prediction. Finally, wording bias. I'll ask you a question. I'm sure you've seen it on TV. Are you in favor of ships that go up to Alaska and they get these baby seals and they just start clubbing them to death? Blood spurting everywhere and they just club all those seals to death. Are you in favor of that? No. Your grandma's dying. Are you in favor if we can do some testing on animals that might save your grandmother's life and cure that disease? Are you in favor if we do that testing so that we can save your grandma? Yes. I'm asking the same question. But am I leading them to one solution or the other? You bet. No, I don't want to kill baby seals. Yes, I want to kill baby seals. Always be on the lookout to how the question was asked. You'll see something in the paper. 72% of people are in favor of no more cars. Huh? What question? First you want to know who'd you ask, right? Did you do a good simple random sample? But then your next big question is, give me that question you asked them. How did you word that question? Because Because if it's poorly worded, you can't trust the results. I'm going to get 100% on both of them. Okay, so be careful that someone's not leading you in one direction or the other. All right, finally, last thing. If you can eliminate bias, eliminate all this stuff. This is something you probably knew walking in the door in August. The larger sample that you can get is going to probably do a better job of predicting the entire population. I'm trying to figure out who's going to win the next election for president. I asked 2 people. Okay, is that going to be a better predictor, or if I ask 200 or 2,000 people? And the answer is, as long as you're doing it correctly, if you can get a larger sample size, that sample is probably going to look much like the population. Okay. Now, if I'm standing outside of Republican headquarters, I could have asked 20,000 people. Right? I've got a bias. Figure's not better. But if you choose your sample correctly with good randomness, okay, from the entire population, a larger sample is going to resemble the population more than a small sample.
And does the sample get too big?
Yeah, it's a good question, right? Because when we say maybe a census isn't so good, so at what point does a sample become too large? It's a great question. I would say probably when you're apt to maybe make errors. Okay, things like that. Okay? Okay.